The rig itself, fit it out as a dummy installation, perhaps a domestic one with a couple of circuits, a lighting radial circuit and a ring final circuit. The idea being to show how you can trace an intermittent fault that's not tripping while you're there. So we have our main incoming here, circuits out to ring final to your lighting circuits, and the fault that we're going to find is going to be mimicked by a socket tester.
Fantastic.
Okay. Yeah. We start by turning it on. Within 10 seconds, the claim I make is that you'll know what you're looking for. Okay. Depending on what this reading is doing, will show you exactly what the fault is. Now, at the moment, you can see, apart from the last digit, it is a fixed reading. That would mean it's electronics.
Okay.
If I disconnect the socket tester, you'll see that reading will drop away.
Okay.
So that is what is causing it, is electronic. If it was actually a fault, the reading you would expect to see would be flashing around as that is there.
Right, okay, so the number would just be
jumping around all over the place. The only thing I can tell you, it probably won't be above 22, 23 milliamps, which is where the RCD would normally trip. We're going to try and find that 1.2 value that is sitting on there at the moment. We start by disconnecting all of the circuits, turning them off.
Okay.
You can see that reading drops away. We then turn them on individually. With that one, it's still dropping, so it's not that circuit. We put that one on, and straight away, there's that reading.
Fantastic. So we'd know from looking at the board, this is the B32, so we know this is the ring circuit. So this is now a ring final circuit. If it was RCBOs in the board, you could just simply check at the top of each circuit. Oh, of course, because the line and neutral
side by side.
Brilliant.
And you can see there, it's not the lighting circuit because that's dropping away. If I then put it on the ring final circuit, there's that 1.2, 1.3 reading sitting there on the 4 cables going away. We now know that it's on the ring final circuit. Okay, so the problem with rings is the current doesn't only go one way round the ring. So when you start trying to trace the fault, if you just went in as it was and go in onto the cables behind the socket, you can see that we've got a reading there of almost 0.4, and we've got a reading on that side of sort of just over the 0.9 value. So add the two together, it comes up with the 1.3 that we know this is creating. So the best bet is to actually split the ring at this stage. Now I've just put in an isolator switch just so that I can do it without leaving live ends anywhere. That has now created 2 radials. So if we go in at this point, you can see there that reading's dropping away, so it's not on this leg. So if this was an actual installation with things plugged in and everything, we've already eliminated every other circuit bar the ring final circuit. We've also now eliminated this half of the ring, including anything that's plugged in. So we now have just got this one leg. Now, when you're using the clamp meter, it will only indicate what's happening down line. So if you then go in and split the ring again, I'll put it in at that point there, and you can see the reading's dropping away, so it's not beyond that point.
Right, okay, so we know we've got to get closer to the board now.
Closer to the board. So we go in at this point, and if it goes, you can see there's that reading. So it has to be between that point there and that point there.
Fantastic.
And as we look, hey presto, there it is.
Brilliant.
Okay, so obviously, when you're actually doing the testing out in the field, you'll be dropping sockets off to get to these cables. I've got them exposed. When we talk about splitting the ring, what you'll find, perhaps it's a kitchen ring, make yourself up a breakout lead, okay, which is this device here. When you come to the socket where you're actually going to split the ring, it's worth considering unplugging whatever appliances are in there, plugging this in, plugging the appliance into the end. You might just be lucky, and when you go into the breakout, find that you found the fault that way. So but you eliminate anything that's plugged in at the socket where you're splitting it.
Fantastic. So what you've done there is obviously taken the earth out, because if we clamped it round the whole thing, we'd obviously find that all the currents in there would be balanced, wouldn't they?
And it would just drop away.
Just drop away, none the wiser. So that's a nice idea. That's very good.
So a little breakout. You might just be lucky, probably unlucky, and find out it's the kettle that you've just unplugged. So when you finish the job, you don't get a cup of tea.
Tragic.
But that's intermittent fault finding just made simple for you.